Hi guys, continue with the definite integral application. Right now we are going to see an example number 2 that is based in area between the curves. This example is very similar to the other one, but in that case, instead to have one function, here we are going to have two functions. The example says, according with the math function f for x equal to cubic x plus square x minus 3x, that is very important that you need to identify, that is this one. I'm going to write over here f for x and g of x equal to x, that is this straight line. Calculate the area between both curves. The area between both curves is going to be corresponded with this first area that I'm going to call A1, and that area that I'm going to call A2. Okay, so it means that the total area that we are going to calculate is going to be A1 plus A2. Okay, let's make the focus for the good. It's better. Okay, so in that case, as you remember, we are not going to calculate the roots. Let's remember what is the root. Root is according with the independent variable. I'm going to take in account that axis, and the root is all the crosses that we have with the function with the axis. For example, this, and this for f of x, and g of x is this one. But I don't care the roots in that case. The thing that I need to calculate are the intersections. In that case, this is going to be the clue intersections for make the intervals of the integrals. We have three intersections over here that I'm going to call A, B, and C. And the intersection, as you can see, is the points that are going to be in both functions at the same time. So for calculating intersection, I'm just going to make an equality between both functions. Okay, so let's try to do it, and then I'm going to write the first function, and this is going to be equal to the other function. Let's make here a clear process, and this one that is positive is going to pass negative, and then this is going to be equal to 0. Those are common terms, and then the result is going to be a cubic x plus square x minus 4x equal to 0. Again, the mathematic tool that is going to help us to know the numbers that put in over here is going to give you 0. I'm going to use I need to break in factors. The first one is going to be the common term, that is x, and divided each element of the common term. I'm going to have x squared plus x minus 4 equal to 0. Okay, and the first point or first intersection that I'm going to get is very simple. Just imagine that you are going to take this trinomial and you're going to pass is multiplying, going to pass dividing in 0 over this trinomial is going to be 0. So the number that you want to have is 0. X equal to 0. This intersection is the intersection B, as you can see here on the draw. Okay, so in other fact, if you want to know the other numbers, A and Z intersections, now we're going to imagine that I'm going to take this one. I'll remember this is non-negative. It's just wanna because of my pencil, but it's not negative. Don't be confused about that. This one is going to pass dividing, and again 0 over x is going to be 0, so the only thing that I'm going to have is x squared plus x minus 4 equal to 0. Again, as you can see, we have a square polynomial. So one form that is possible to know the numbers that is going to produce the 0 is to break in factors. But for example, the factor 4, the factors of the 4 is 4 by 1 and 2 by 2, and any one is going to give you 1 adding or subtracting, so it means that you cannot factorize it. The only thing that you need to do is, again, to use the general formula. A is 1, B is 1, and C is minus 4. Let's calculate again with the general formula, minus plus minus the square root of B minus 4 times A and C. Let's calculate the intersection A and C. Here is going to be A and here, B is going to be here, and finally C is going to be over here. So x is going to be minus 1 plus minus the square root of 1 squared, that is 1, minus positive and minus is going to be plus. 4 times 1 times 4 is 16 over 2. So it means that x1, I'm going to call it 1, is going to be minus 1 minus the square root of 17 over 2. And x2 is going to be minus 1 plus the square root of 17 over 2. Those are approximately, let's take the calculator. Let's see, it's going to be minus 1 minus, first the fraction, minus 1 minus the square root of 17 over, I wrote 14 is 17 over 2, and this is going to be approximately minus 2.5615. As you can see, is correspondent with this point that is between minus 2 and minus 3. So it means that this is going to be A intersection, and the other one should be the intersection of C. Minus 1 plus the square root of 17 over 2 is going to be 1.5615. That is correspondent with this one, that is between 1 and 2, has this number same. Okay, so this is going to be V. Remember guys, it's very important that do not use these numbers. Well, if you don't have an option, you can use it, but it's better that you use this fraction because this is going to be exact. Okay, well, let's start to make the statement of the integrals. Remember that you are going to make two integrals, but it's very important, very important, like I told you in the last example, that you need to draw the representative rectangle. And here, remember that the base of that rectangle is going to be dx, but here is very important to know who is above and under that rectangle. Above is f for x, and under is going to be g of x, because the integral is going to be, in that case, remember, is the above function minus under function. As you can see, with this one is the right form to calculate the integral, the area under the curve from A to B. Okay, so that's why it's very important. Okay, let's make, here is going to be the integral from A is this one, minus 1 minus the square root of 17 over 2 to B, and B, remember, is 0, of f for x. F for x is this one. Okay, I'm gonna write over here x cubic x plus square x minus 3x minus g of x, that is x. I'm gonna write over here, x, everything times dx. Okay, if I develop the first one, is going to be minus 1 minus the square root of 17 over 2 to 0 of, this is going to be x cubic plus x squared, and as you can see, if I disappear the parentheses, is going to be minus 3x minus x is going to be minus 4x dx. And this is the first integral that I'm going to use to calculate the first area, the area number 1. Okay, so let's continue with area number 2. Area number 2 is going to start from here, that is 0 to C. okay, and C is going to be I'm sorry, I made a mistake over here. It wasn't B, it is C, okay, from minus 1 plus square root of 17 over 2, but in that case it's going to be, look at this, I'm going to make the representative rectangle, but above of that representative rectangle I'm going to have gx, and here under I'm going to have f or x, so this is going to be to the inverse to this one, so that's why here is going to be gx minus f or x. So that's why it's very important that you draw the representative rectangles, differential rectangles, okay? Do not forget that. You should do it. Okay, so here I'm going to have the integral from 0 to minus 1 plus the square root of 17 over 2 of, in that case, g of x is x minus the f for x, that is going to be cubic x plus square x minus 3x, everything times dx, okay? So here is going to be equal to the integral from 0 to minus 1 plus the square root of 17 over 2 of, according with the parentheses in the multiplication of the negative, is going to be x minus cubic x minus x squared plus 4x dx, okay? And according with this and this are common terms, so the final statement of the second integral is going to be from 0 to minus 1 plus the square root of 17 over 2 of, is going to be minus x cubic x minus square x plus 4x dx, okay? So I have the first one and the second one area. So let's try to do it. Remember, you need to do it by hand because you need to practice. You need to practice the rules seems in the unit number 1. And then if you have a calculator, remember, use the calculator to verify the result that you got it, okay? So let's start to use the calculator. I'm going to press this key that is the form of the integral, and then the first thing that I'm going to introduce is this one, that is the for the area number 1. I'm going to press alpha x and then the power cubic, okay, plus alpha x squared minus 3 alpha x, okay? And let's start with the intervals. The inferior is a fraction, okay? I'm gonna write minus 1 minus the square root of 17 over 2, and the superior limit is going to be 0, okay? Let's start, and then just press equal, and the area number 1 is 4.6814. This is remember, this is very important. We are talking about square units, okay, because it's talking about area. Okay, as you can see, we got the first one. Now let's introduce the second one. Again, the integral of, now let's introduce this data that we have over here. It's minus alpha x potential cubic minus alpha x squared plus 4 alpha x, okay? And the inferior limit is going to be 0, and the superior limit is going to be a fraction, that is the limit c, that is minus 1 plus the square root of 17 over 2, and this is going to be, okay, you will have 2.1211 square units, and then the total area is going to be only the addition of both, is 4.6814, okay, plus 2.1211. Good. And the total area is going to be 6.8025 square unit. And we finished the example number 2 about the area between two curves. With this example and the example number 1, right now you are able to do the evidence number 1 of the unit number 2.